Hello, everybody. My name is Elham Gabuli. I'm going to present you the first part of today's presentation of RhinoLands, and then my colleague Francisco Saya will continue with the live demo. Thanks for joining this webinar, and let's just start. RhinoLands is a BIM solution for landscape architecture, and I'm going to present you the first part, which is the overview and main features of the program. So it's a BIM program. It includes tools for technical drawings. Then also it generates the 3D model of the project. It automatically generates the list of plants, walls, and all materials that we have been using during the design process. And also there are several tools for visualization of the project at the end. The program is standalone. It already includes Rhino 8 for those of you who know Rhino. So as you see, it has a simplified interface. It started from drawing, modeling, terrain, vegetation, irrigation, and documentation tools. So behind the program, Rhino 8 is running, but Rhino 8 is enhanced with Lands Design, which was a plugin before. So right now, RhinoLands is the standalone program. So the program is used for landscape architecture, for green infrastructure design used by civil engineers, for urban planning projects, and for environmental projects. For example, we can easily model a forest by using the program. Let's see its main features. First of all, the program includes an extensive plant database with more than 8,000 plant species. The plant database includes several filters that help us to select the adequate plants based on different parameters like soil type, climate type, or aesthetic parameters like a flower color, for example. As you see, there are different blocks for the same plant species, a realistic 3D model, and also there are other blocks that are going to be used in different displays. As you see here, we have different displays like rendered, shaded, or wireframe. And you can switch between them by clicking on the realistic, detailed, or conceptual. In realistic, we can change and switch the seasonal change of the project. So we can see how would be our landscape in summer or winter or in different periods of the year. So by moving a slider, we easily can have an imagination of how would be our landscape. We can switch between 2D and 3D easily just by one click. As you see, there are specific blocks that are going to be used in 2D environment, and in 3D, we have realistic 3D blocks. For inserting plants, we can use different ways. We can insert them individually. We can use inserting them by moving the mouse on the plot. The program inserts plants randomly. We can convert points to plants or blocks to plants. So if we have AutoCAD blocks or any kind of blocks, we can convert those blocks to a specific plant species in the program. We can insert a row of plants by indicating the distance and combination of plant species, or insert a group of plants, again, by indicating the distance, the arrangement, and plant combination. We can insert shrubs by indicating the number per linear meter, or also insert ground covers. Inside of plant database, we have a plant editor that helps us to edit an existing plant, the appearance of the plant, and save it as a new plant species or as a modified version of an existing one. There are powerful tools for creating and generating terrain. As you see, we can convert points and lines to a 3D terrain. Once the terrain is generated, we can do different types of earth moving operation on top of the terrain. So we can do cut and fill, create a path, divide the terrain, and so on. Finally, the program calculates the volume and area of earth moving. We can generate a terrain by using a DEM file or by indicating the location on the map. Program inserts the terrain in 3D format, and we can obtain from that 3D the 2D, let's say, topographic contours of the imported area. Well, by using the terrain tools, we can easily compare different alternatives for the same project. By comparing the result of fill volume and dig volume or the area, we can choose and we can have a better decision making. And all this operation takes a few minutes. There are dynamic documentation tools that help us to select, to produce the documents of a project. We can add the label of plants, then get the number of any plant species, add the image of plant species. We can also in continue generate the dimension plans and different types of drawings. And then also we can produce different type of sections and conceptual plans and so on. So all this kind of documentation are available in RhinoLands. In addition, we can also obtain the list of plants and materials. There are parametric hardscape tools that you see here. We have parametric walls, curves, parametric paths, parametric fences, and stairs or ramp even. And also there is a block library of furniture inside the program, but you can import any other furniture that are compatible with the program, for example, SketchUp blocks. We have irrigation tools in 2D environments, so you can design the irrigation system and place the sprinklers and pipes, and the program finally calculates the material that is used in irrigation system design. For visualization, we have walk mode. We can walk through the project. We have sun and shadow tool that you see here, which is quite unique. By moving the slider, you can see how would be the shadow movement in our project in different periods of the day and different periods of the year. Also, we have render possibilities. There are the most important render engines in the market are compatible with the program, and we have some image filters as well. So without using any external rendering engine, this is the Rhino render. This is the internal rendering engine of the program. So we can get to somehow a realistic result. But if you apply any other external render like Enscape, Twinmotion, or V-Ray, or Lumion, these are the examples of the results. The animation that you see is made by Enscape, but based on a model that is designed and developed in RhinoLands. So in this way, we can bring our projects into life. Another unique feature is that we have parametric design possibility by using Grasshopper in RhinoLands. So we apply algorithms by using Grasshopper to generate a geometry, like the geometry that you see in this image, or we apply a Grasshopper to link the external data to a BIM geometry and do different types of analysis. And we'll see the examples later on. So these are the Grasshopper components of the program. As you see, we have components for everything, every object, every landscape object that you see. So you can apply algorithms to generate a terrain or to generate a forest and so on. So let's see a simple example. We are going to insert a group of plants with different diameter, and we are going to have the plant pots with the same diameter of any plant species. So by using and the related or the created algorithm in Grasshopper, we just by clicking on a button, we get the pots, and by moving the plants, the plant pots are going to be moved automatically. They are linked to plant species. This is a simple example of applying algorithms, but you can imagine how many possibilities we may expect from this linkage. Well, another use of Grasshopper in our case is the environmental analysis. This is something that we promoted and we developed recently. So we link environmental data to a BIM geometry in RhinoLands. And in this way, we do different types of analysis. One of them is CO2 calculation. So we can calculate after designing a park or a landscape, we can calculate how much CO2 or how much carbon will get sequestrated by implementing the project in 10 years, in 20 years, or in different periods of the that you want. So we can calculate the cooling effect of plants. So we can see that how would be the cooling effect of plants on the surface. We can calculate the shadow, so the percentage of shadow coverage during the daytime and during summer or winter. And also we can calculate solar radiation. We will see the example later. So this is the carbon calculator that we have promoted and we have developed recently. So the calculator, the definition is available in Grasshopper format. And by linking this definition to your model, you can calculate how much would be the carbon that is going to get sequestrated in 10 years, in 5 years, or in whatever period that you want. Also, there is a BIM workflow by using the program. So as you see here in Revit, we can call different objects, all objects categories of RhinoLands, and Revit will recognize them as BIM categories and as BIM objects under their own family and its own categories. So we have IFC file format support. So let's see how would be the design process. If we have topographic contours, we can elevate them and generate the terrain. And if we don't have topographic information, we can import the terrain just by looking the location on the map. Once the terrain is imported, we can add a boundary to terrain, create different type of operation like cut and fills, or create a path or a hole, for example. And we can continue the design process by adding hardscape objects like walls, which are parametric, fences, stairs, or ramps as well. So you have a full control of the detail of fence or wall or all other hardscape objects. In continue, we can add furniture to the model. So you can use the block library that you see here, or you can import any other blocks that you have, like 3D Max blocks or SketchUp blocks. But the program will count the number of these blocks as well. So in continue, we add a vegetation. As you see, we use the block library for inserting different vegetations. And the plants have their own 2D blocks. So as you see, there are specific 2D symbols for any plant species. You can change the arrangement of plants, use array system or a matrix of plants, indicating the distance and so on. You can add the label to plant species. And in this way, you produce drawing and different layouts. You obtain the list of materials, plants, walls, stairs, and so on. And if you switch to 3D, again, you can switch the seasonal and change the seasonal season of the project. So you can see how it would be in summer or winter. And finally, if you shot a render, you will see how would be the final result in a more realistic view. So this is the workflow that we recommend. Basically, if you can do everything in RhinoLands: drawing, modeling, and documentation. But if you are coming from another background, like for example from any kind of CAD background, like AutoCAD or SketchUp or any kind of file formats that are compatible with the program, because Rhino reads more than 50 file formats, so you import or open them directly into RhinoLands. So you open your drawing, your DWG file, for example, and then you continue inserting blocks and inserting RhinoLands objects. In continue for visualization, you can shot a render using Enscape, V-Ray, Twinmotion, Lumion, or use a virtual reality headset, or print your project with a 3D printer. For documentation, you can export your documents to Excel or PDF, or generate your layouts directly inside the program. You may have collaboration with other programs like import and export files from Revit, SketchUp, or 3D Max through IFC or through inside Revit technology. And if you have geographic files like GIS files, digital elevation models like point clouds, and if you have even LiDAR point clouds, you can import them into the program, and the program will generate mesh or a terrain based on the imported data. So you can do the whole project inside RhinoLands, from different drawings, different layouts, to the realistic 3D model of the project, different sections and views as well. This is a real-world application of RhinoLands green infrastructure in Madrid. And as you see, all the model and documentation is made inside RhinoLands. And in summary, there is a 60-day free trial of the program. The licenses are permanent, but we have also the subscription option for those of you who are going to use it for a short period of time. You will have free technical support for whatever technical issue that you are facing. And you will have, there are educational and lab licenses for students and teachers at a very reduced price. Up to now, is there any question? Or we can continue with Frances, who is going to share the second part.
Thank you, Elham.
You're welcome.
All right, so we'll continue this session by seeing in a live demo more or less what we have seen in this nice presentation. So first of all, I would like to introduce you the interface of RhinoLands. Those of you that have used Rhino before may find familiar well, this interface. So it's actually a simplified version of Rhino in order that it's easier to understand, easier to use from the very first moment when you try RhinoLands. So here we can find all the 2D tools that are necessary to draw in 2D, also to do operations in 2D. Same for 3D objects. We can draw anything you like, you know, as primitives, tools to do extrusions from 2D curves, to do operations with 3D geometry. Everything natively in Rhino is available here. Then we can find some terrain modeling tools, also vegetation commands, also tools for creating civil work elements. These are smart objects, as we'll see in a moment. Some irrigation tools, also documentation tools to list everything that we have in the model, from plants to fences to zones or terrain and land movement. And also anything that has to do with annotations, scale dimensions, or commands to open paper space, like you have in AutoCAD, for example, to present your project from a page layout. Okay. In addition, we can find here some visualization tools to navigate through the project in walk mode, to change the display of what we're seeing here. Actually, some of these tools are available also from the menu in the viewport. And well, we have here some shortcuts to do basic operations, basic actions, such as copy, move, rotate, scale, and so on. And finally, on the right hand, we can find some panels from where we'll be able to edit what we are selecting, okay, from simple geometry, okay, or we have here some options to see the layers of the project. So if you're familiar to AutoCAD, for example, RhinoLands also manages the geometry and the attributes by layer. So we'll be able to create our layer structure here. And some other well, panels to control the materials, the sun, shadows, named views, and so on. Okay, we will view some of them. Again, here you have the command line. The learning curve is pretty simple because every command that you run, you just need to follow the instructions in this command line. And again, since RhinoLands has Rhino natively in the program, you can run here any command available in Rhino, even though including those that are not maybe listed here through the command, through the toolbar. So you will find them here. Okay, so any word you type here, you will see the related commands. Again, that those that from you that are familiar with Rhino, you can also run Lands design as a plugin on top of Rhino. So you will work as you have used to with Rhino, and you will have all the Lands design tools, okay, available with this specific toolbar. But today I would like to show you the this presentation through the new RhinoLands interface. Let's imagine a typical situation from where we could start a new project, which is to to import DWG file. Okay, so I'm gonna open a new document. I mean, that's something that maybe you have received, a document you have received from a collaborator, okay, a DWG file, or you can also create all the 2D curves in RhinoLands. So you will find some import options dialog, accept all the standard values. And basically we get here the document with all the lines here distributed into different tabs, different layers. So we can show and hide them from here. And well, we can edit these curves through control points with a gumball. We can start drawing the model based on these curves. Okay. Okay, let's do a jump forward and just imagine that we have continued modeling this project. So I'm gonna show it a little bit more advanced. Okay, so this is a part of this project developed from that DWG file. And well, let's take a look at this the existing geometry, because here we already have some plans, okay, some areas as well, some curves that we'll use to generate terrains, okay. But first of all, let's take a look at the edit panel. This dialog shows the features of the objects that we select, properties, and actions that we can apply on the objects. Okay. When we don't have anything selected, we see here the document parameters. For example, here we can change the display mode of the project. We can go from 3D to this 2D representation. Okay, where plans are displayed with a 2D crown, terrains, as we will see later, are displayed as contour curves, and so on. Also, we have here a setting out symbol that we can see instead of the 2D crowns. So also plans have a double representation in 2D. Okay, but let's put this back to 3D. Also, there are different representation modes in 3D for plans. So we have the elevations, we have a conceptual shapes, we have a detailed, and finally the realistic representation. And each one of these representations use different blocks. This one, the realistic one, is actually using a representation, a block that can handle different appearances. And you can have each appearances assigned to a specific season. So one of the parameters of the document is the season from which we will show the render. Now we're seeing the plants in the spring representation, but if we change that to winter, well, the preview of these plants here will change to the other representation. And now if we show the render, these plants will be replaced by a more detailed plants. So we'll be able to see even better resolution for all the textures on the leaves and the trunk, the branches, and so on. Okay. So this is basically some options for the display, but that also apply to render results when we want to produce beautiful images. Also, well, this realistic representation can be switched to billboards, because in a situation where we have like maybe hundreds or dozens of plants, I mean, and we want to have a good performance, we can choose this option. So we'll have a very nice performance, even though we have a large amount of plants in the model. Okay, but well, since this project is not so big, I'm gonna use the 3D representation. Okay, so we can start by inserting one of these plants. Okay, we'll maybe do it close to this this plant, some part of it. So I'm gonna run the plant command. So we get this insert plant dialog. Here we can see a list of the species that we have already used in this document. Of course, in a new document, we'll have this list empty. And then we'll need to click on this button to browse the plant database. And as we have seen before, we can select and we can search plant species all over the world according to all these criteria. Okay, here on the header of this dialog, we can see the number of species that match with the selected criteria. Okay, as we add more filters to this search, we'll see here the number of plants that match with these parameters. We clear the search if we want to restart it. And also, there are a few lists here, predefined lists of plants according to some criteria. Actually, we can select the plants that have a specific realistic representation developed for that species, because I mean there are no 8,000 realistic representations for all the plants, but some of them can be used for several species. Okay, but well, I mean, if we want to see them all, we just select that. There are also some lists for plants that are suitable for vertical gardens. Okay, and well, other lists here. Also, we can click here next to any desired species to have a list of favorite plants. All right. Okay. Also take into account that you can create new plant species that are not in the plant database, and you can do it by duplicating an existing one. I mean, we can select any of these species, create a copy, and edit the copy to change all the species name, the representation mode, and so on. Or we can create a new species from scratch. We click on this new button, and we'll have this empty technical sheet where we can well, fill all the form, assign all the morphology and the characteristic details. Also assign to the crown for the to the representation of this plant in 2D. So there is a library of different blocks for the 2D crown available, which can be expanded by your own 2D crown. I mean, you just need to save a file and have it in that folder. Okay. And same thing for the 3D conceptual shape, the detailed shape, or the render, which I mean, we can explore the different files for the render, for the realistic representation. You can find over 600 or 700 different files. Okay, they're using a specific format that are generated with a plant editor that you can also download for free. And I mean, you can even develop new of these realistic representations for well, for adding it to a new species. Okay. All right, let me cancel this. I'm gonna insert any of these plants, for example, this one. I mean, you define here the size of it. If you're gonna insert several units, it's interesting to apply this option, because then you'll have a slight differences in height. So, and also with the random rotation, each plant will look a little bit different from one to another and give more realistic feeling. Okay, even though the same plants, well, both plants are using the same block. Okay, I click now. Okay, I can insert my plant, and now I can select it. And from the edit panel, we can change the species if you want. We can change the height. We can see here some other information like the format, render. Okay, so there are different options available for the objects that we insert. We can click here, edit the species. Okay, so we can change also the 2D representation, 3D representations for the plants in that document. I mean, if we apply changes on the plant database, it will affect other documents, but these changes can be applied by document, okay, from by editing the species from this panel. Okay, so before we insert a few more species, let's see how the terrain modeling tools work. This is some of the most powerful functions in RhinoLands, because, well, as we have seen, we can create terrains from curves, points, we can import them from the web, we can create them from GIS data or DEM files. In this case, I'm going to show how to create them from curves. So imagine that we got 2D file with all the contours as these lines that we have here, and they are meant to be contours of the terrain. In this case, all the curves are on the same elevation. So if we created the terrain right now from these curves, we'll actually get a flat terrain, right? So the first thing that I'm gonna do here, I'm gonna change the display mode to wireframe, is to elevate these curves. So from the terrain tab, we've got this command that, well, we need to define a start dimension, an increment of the curves. I will set it to 1, and draw a line that will elevate all the curves that intersect with it. Okay. When I click apply, all these curves elevate 1 meter starting from 0 elevation. Now I have the curves in the desired position. These curves don't need to be flat. I mean, we can have any of these points, you know, like more elevated than others. So they could be actually any kind of 3D curve in the model space. When we create a terrain out of them, the terrain will try to fit with the points of these curves. Okay, so let's see how it looks like. I'm gonna run the terrain command. I need to select the curves. I mean, we just need to follow the instructions here in the command line. And yeah, I will select all these curves, including a point, why not? And hit enter. I'm gonna cancel. I just want to make sure that I don't choose this rectangle. Now, here, this is the terrain insert dialog. We can define the terrain precision. Okay, so basically we define the cell size. So the smaller the cell size it is, the better accuracy we'll get with the input curves that we have selected. Okay, so basically I'm gonna set it to 1 meter. Also, we can assign a material to the terrain by default. Actually, there is a library of materials available, so we can change that for any other textures here. So you can explore that if you like. Of course, if you are using V-Ray or other render engine that provides a library of materials, you can use them on these objects. So it's totally up to you. But, well, we click OK. And we'll see here, maybe in rendered display, we can enable this from here, the terrain created already. These curves are not linked with the terrain anymore. I actually had them in a specific layer that I'm gonna hide from here. But if we select now the terrain, you will see that it has some control points, which are actually the same control points as those curves that I've used to generate the terrain. I can use maybe as some of these control points to modify the topography of the terrain. Okay. I can also show this terrain in 2D and 3D at the same time, so we can have a better feeling of the topography of it. All right. By the way, this terrain is covering an area that I didn't want it to cover, so we can see some of the tools available to fix this. For example, we can define a new boundary for the terrain. Okay, with this command. I'm going to switch to wireframe. Again, run the terrain command. So I'm going to select the terrain. Now select the curves. Oh, excuse me. Let's run this again. I run the boundary command, select the terrain. Now select the boundary curve, which I previously drawn, of course. And now we can see the terrain trimmed by this curve, this boundary curve. Okay. All right. Let's take a look at some other options for the terrain tool. For example, let's insert here a path. Okay, we have here a tool to add paths according to a path curve. So I already have here a curve, okay, that I'm going to use it for this purpose. This curve is in the 0 elevation, so I will leave it like it is here. By the way, I can also see here there is a gap between the terrain and the existing area. There is a way to fix this. I mean, we can add new contours to the terrain, to modify the topography as, we had included that curve from the very beginning. So first of all, I'm gonna draw here a polyline or a line. Okay, I can use also the snaps here to snap on any of these points. Okay. And now I have a curve here, is this one, right? I can add this curve as a new contour for the terrain. So I'm gonna run the terrain command. We'll select this option here, add contour. So I pick the terrain. I'm gonna select this curve. And hit enter when I'm done. And then, as you can see, we have a better meeting of the terrain with that part of the park. Okay. Now let's back to the path operation. So I'm gonna run the path command. I will select the terrain. I will define the width of the path, for example, 3 meters. And finally, I need to define an angle, basically how the path will meet the existing terrain. Okay, the angle by which will meet along all the path axis. 45 degrees is fine. And finally, I will select this curve. Just notice that I have this option to divide set to yes. This will allow me to change the material assigned to that path. Okay, so now, we can see that the terrain has this modified in order to fit with the position of that curve. If we select the terrain, we'll see that we have this control point integrated into the terrain as well. So we can, change that by manually pulling this down. Okay. And also, if we select now the terrain, we can see here in the edit panel all the different operations that we have applied. So we have on one hand that boundary curve, right? We have here this earth moving operation, basically the path subdivision. And when we select this, we go to the path and we have different options to calculate the grades. Okay. Now, this this operation has been done on the existing position of the curve, the curve elevation. We can choose this option to basically try to find the less modification of according to the existing terrain, or you can explore the different options, but I'm gonna show you this one, the grade, because this will let us create that path according to a regular slope. Okay. As you may have noticed, this is not what I wanted to create. So there is here an option to invert the curve. Okay, so it will flip, the direction of this curve. So in case, you can do it in advance, but if you want to do it later on, you can do it from this option here. And now we can set here a different percentage, like 5 meters, or also choose any of these other options to define the grade of the path. Okay. All right, let's maybe see another operation we can apply. We have this curve here. In this case, I'm gonna create a cut and fill operation. So we'll move this curve a little bit upwards. So in a position that intersects a little bit the terrain, but on the other hand, it flies over it. I will use this curve to flatten the area over this rectangle. So we'll need some land movement to fill this part of the terrain below the curve, and some other to cut it. Okay. So I run the cut and fill command. I select the terrain. Again, I need to define an angle. Okay. Later on, I will be able to change that angle according to the cuts and fills, but right now I need to select one for everyone. And finally, I select the curve. So I get this as a result. And now if we select the terrain, we'll see this operation listed under the earth moving operations. So we can see here the cut and fill, and here we can define different angles for cuts and for fills. Okay, if this inclination is too big, we can maybe make it more soft. Can soften it a little bit. All right. Also, we have this double arrow. I mean, we can change also the boundary curve from these grid points. Okay, and we can move the whole area with this double arrow grid. So you can change, this contour at any time. And well, since we have applied some operations on the terrain, let's list the results. Okay, so I'm gonna work from the top view. In this view, I'm using a 2D representation, and I'm gonna move to the documentation toolbar, select the terrain list, and insert it in the model. So this terrain lists the area of both operations and the volume of fields and digs for each one of the operations. Okay, this is a list that is linked with the model. Okay, so if, for example, if we change the the angle of this operation as we did before, we set this to maybe back to 45. You will see that these values have updated. Okay. All right. Let's maybe populate a little bit more this terrain with plants. Okay. Take into account that any object that we draw on top of this area will detect the terrain and will be created on top of it. So we don't need to care about the elevation of the objects because they are automatically placed on top of it. And of course, you can change that if you like, but by default, it's very good to have them, automatically projected. I'm gonna work from the top view, and maybe we can create a forest on that area. Okay, so I'm gonna run the forest command, select one species. Well, here, of course, define the height. It's interesting, of course, in forest to check this option, natural variation and random rotation. And here we have the forest parameters, so we can define the total amount of units, the minimum distance between each unit, or we can also choose an option to array, distribute the plants in a regular array mode. Okay. I click OK now, and we can either select a boundary curve, an existing one, or we can draw it on the fly, basically selecting any of these shapes. I can choose polyline, for example, and just start drawing the boundary here from the model space. Okay, as you can see, the size of the plants are all different, slightly different. And now I don't need to close this, the polyline. I can do right click to end the command, so the boundary will be closed automatically. And okay, I will take a look at the model from the perspective view, just to double check that plants are projected on the terrain. Okay. Well, any change that we do on the forest, for example, we can change this distribution, the distribution of it. Okay, as many times as you like. We can also clear an area within that boundary. For example, we can clear the area for that rectangle, so no plants are located inside it. I mean, this option is available also from the forest. We can select this add hole option, select that curve, and this area will keep clear from trees, no matter which is the distribution we have. Also, we can change the plant size, and we can combine species inside this forest. We need to select the forest, and here we select more than one element to combine different species. So now we have these two species here hanging from this forest. We select one or another, go to the plant tab, and change the species. Okay, and we'll be able to edit the parameters of each species by selecting them from the forest. Okay. Selecting the forest, we will be able to change the other options, like want a regular array, okay, change the spacing of each of all these array and so on. Okay, well, we have inserted a few plans. Maybe it's interesting to show also the ground cover feature. I mean, this object uses a different representation of plant species, and also in 2D are represented as a 2D as a hatch pattern. I mean, we can browse in the plant database for what species that are suitable for ground covers. Okay, and well, we define some density, plant scale. Maybe I'm gonna make this smaller, and maybe I can draw here using a rectangular option. The ground cover on that area. Okay, so maybe you can appreciate it. You can later on change that ground cover. We can maybe change the plant scale, make it maybe a little bit bigger, or maybe provide a higher density of it. Okay, so it's more visible in the model. And of course, this will project automatically on the terrain, no matter which is their its position or elevation. Okay. Now, since we have inserted several plants, let's also insert a list of them. So again, from the top view, I'm going to use the plant list command. I insert it here. If we select this list, we can edit it, and there are some parameters available from the edit panel. We can change the appearance of it, okay, and well, which properties or fields are displayed here. For example, I can enable the density, so the species used for ground covers will show me here the density of them. We can also add custom parameters here. And also we can apply filters. And these filters can be done based on layers, okay, or regions. Imagine that we want to list only the plants that are sitting on the forest. So I'm gonna basically use the same boundary curve to define that, that we used for the trimming the terrain. I will use that curve for the boundary of the region of the plant list. So I'm gonna select the plant list. Now, from filters, I will select this option, select a boundary. And now the plants, I see the plant species correspond only to those that are located in that region. Okay. And of course, this is a plant list that is linked with a 3D model. Any change on it will update the results in this list. List can be exported. Okay, we can well, here we have the options to export that as a CSV file or HTML file. So we can see a preview of it. All right, before we end, I would like to show maybe some of the civil work tools. Okay, maybe I'm gonna insert here a row of elements, just using this curve that we used for the path. So there is an interesting command here for inserting row of elements from the library, because RhinoLands provides a library of blocks for different elements, urban fixture, lighting, bollards, fountains, okay, and so on, stones. So maybe we can select any of these lighting. And well, there are some orientation parameters here. Also, we can define the separation of items or the total units. Maybe 6 meters. I'm gonna place one street light, and well, I'm gonna choose here the distance to the axis of 1.5 or 1.8 meters. So, I mean, the row is not sitting exactly on that path. And finally, I need to select the path. and well, have all the rows, the element row here, okay? Which later on we can adjust with the desired modifications. For example, here I can select this sample, and I can make it perpendicular to the axis. I can invert it to face the desired size, and I can go to the row and maybe change the separation up to 8 units. Okay. And well, another object that I can show maybe it's the ramp command. So here we have a stair, by the way. The stair is a parametric object, so we can change parameters from here. Well, the width can be changed to 1 meter, and I can align it to left, and maybe I can create a ramp on that part of the project. So I'm gonna draw it from the top viewport. I'm gonna run the ramp command. Well, here you have all the insert parameters. For example, the start height would be 0. Well, this extension is when you have ramp with more than one flight. I'm gonna align it to left, okay? And if I select the flight, I will be able to select the slope by a total height, a percentage, as we saw with the path on the terrain. In this case, I'm gonna change this to 0.4 meters, which is the elevation of this slab. And well, finally, change the start width. I can select this button to measure here the approximate dimension. Let's consider this is half meter and a half. And finally, we can draw the path of the ramp. We can select also any kind of 2D curve, could be also spline, so we could have like curved ramps. I'm gonna just use a polyline here. And I'm gonna just pick up any point in here. And now we can see the ramp represented with a slope on annotation, and it will see it in 3D. We'll see it nicely created here. All right. So I would like to end this presentation with a basic animation. Actually, RhinoLands provides tools to run animations. This is done from this animation panel. Remember that from here you can see you have a shortcut to open the basic panels. Maybe it's also interesting to mention this sun panel, from where we can create quick shadow analysis. Okay, we can enable the sun, and based on the geolocation of this project, we can, define a moment of the year, a moment of the day, and visualize how the shadows will change during the different moment of the day and the year. But now let's go to the animation panel. I'm gonna show here a layer where I have a curve that I created before, and I'm gonna use this curve for a camera path. Okay, so first, that thing that we need to do is to click this button to assign this curve for our camera path. We can hide it now, and we can define the animation frames per second or total duration. We can decide also if we want to use the current render or the Rhino display. This option is good to have a quick preview of how the animation will look like. So for example, if we click play, we'll be able to see very quickly, how the animation goes according to this camera path. Okay. And of course, you can save this animation to a specific folder, click on this render to save it. So, okay, Elham, let's see if we have any questions, and we have some minutes for answering them.
Yeah, there are some questions. Well, first of all, the educational license, which is quite common, was quite common in questions. Well, yeah, we can take a look at our website. Maybe there are educational licenses for students and teachers. So even if you are, you are a researcher, or you are doing an internship, and still you may have the chance to use the educational license. And then there is a lab license for schools. which is offering the use of up to 30 users simultaneously. So if the case, well, yeah, this is the lab license. Well, there are also some questions about blocks of people or cars. We have blocks of people inside the program, but there are no block of cars yet. But I'm sure you can find it easily on the web. There are free blocks available in SketchUp or file format or in Rhino file format. Then also there's another question about the compatibility with Enscape.
Yeah, I mean, since RhinoLands, I mean, Rhino is compatible with Enscape, there is a specific plugin to do a live synchronization of the models with Enscape. It works perfectly with all these elements that we have here. Just take into account that these plans will show up in Enscape according to the level of detail that we've got here. Okay, if we show for example, the conceptual shapes, so this is what will be transferred to Enscape instead. So the level of the appearance that you have here in the model is what you will transfer to Enscape.
Jacob is asking if he needs Visual Arc to do that. No, you don't need.
No, Visual Arc is a different plugin. It's more oriented to architecture and production of 2D drawings. They combine together with RhinoLands or Land Design. But I mean, for connecting with Enscape, not at all. I mean, they are separate.
Oh, but sorry, I know that was I was adding to my previous question, which was like if it exports to IFC 4.0, and if it does, do you need to have a Visual Arc to do it? Because like if you can export the lens design module to an IFC 4.0, so
not yet. The export to that format is not available. It's not available yet in Visual Arc because we are working on that right now.
Okay.
I mean, we are. Probably in the next update of Visual Arc 3, it will be available, and the next step will be including it also in RhinoLands. So the idea is that all the IFC features for importing and exporting.
I understand. So far it's like 2x3 or something like that. If I'm
yes, correct.
Exactly. Okay. Also, I would like to ask if you want to do like this 2D construction documentation. Do you also need to have like a Visual Arc? Is it true? Like
no, not really. I mean, what we're seeing here is pure land design 2D representation. So Visual Arc is not interfering here, but you can combine both. I mean, Visual Arc provides an option to show a plan view representation of elements, but it's totally compatible with this 2D preview or 2D view of landscape elements. Okay.
Okay.
But, I mean, there is no Visual Arc at all in this model.
Yeah, I mean, but for example, for the sections, I think that you would need something to like have the kind of like the soil layers and everything hatched and such a things. Which is another question. Does the cut and fill support the multiple soil layers and show the ratio of the soils?
No, unfortunately, it doesn't. So this terrain has only one layer.
Okay.
I mean, you can do all these modifications, all these operations, but it will be still one layer. If you want to add more layers, you need to do it with additional, surfaces, or maybe you can use this path tool to assign another poly surface on top of it.
Okay.
So you have different layers.
Yeah, but you are basically not able to like count the amount of cut and fill over different layers, so that you cannot do it right now, right?
I mean, you can quantify these cuts and fills according to the different operations, as we have seen here. Okay, and the volume.
Yeah, sorry. So only combining like multiple sort of like cut and fills together to get the ratio right. Is it true?
Yeah, I mean, it compares the original terrain with the terrain after these modifications, and for each operation you get the fill and the volumes.
Well, if you have several operations, several cut and fills on the same place. Imagine that you are going to have a flattened area, and then you are going to have another cut and fill in a deeper area, right? So you can do that.
Yeah.
So you will have cut and fill number 1, cut and fill number 2, and with its own data.
Yeah, right. But you need to have like multiple meshes and multiple cut and fills, and then you can combine it to get the actual ratio of the soils, right?
Yeah. If you are,
Okay.
yeah. If you need
but
the
all of them
quantity,
will be listed.
Yeah, it's a kind of like a bit like a hacker way how to do it, right?
Yeah, I mean, you can combine different cuts and fills, of course, to get different cuts with different slopes in your terrain. But all of them will be listed here.
Yeah. So maybe like the last question, can you add like your custom parameters to the plants, for example? Like if it has, I don't know, whatever, if it's tree or something like that, or if it's I don't know, whatever, like a custom parameter, if you know what I'm talking about.
You can do that from the options, from the document properties, actually. This opens, the same dialog that you have in Rhino, basically. And there is a section here under document properties called parameters. Okay. This actually also shared with Visual Arc. I mean, you can do it in both programs. And here you say, I don't know, planting date, for example, whatever.
Okay.
Okay. And then you define here a category, some data type. There are different options. And when this is done, you select here the objects. Okay, go to these properties. And under this parameter section, here you can assign, whatever value. Finally, in the plan list, once you have created a new document parameter, you will be able to add this parameter as a property field in this list. Okay, so you will see that listed here, and you can do that with any other new parameter.
Oh yeah, that's actually pretty useful. Yeah. Does it also work with if you export it to an IFC or use the Rhino inside Revit? Does this also export to Revit like that? Like that you have these parameters in a schedule in a Revit?
Correct. These parameters, I mean, the values assigned to objects are exported as IFC properties. So if we export that model to IFC, all these plans will have this information stored in the geometry. So you will be able to read it in Revit, for example.
Okay, I see.
Well, another workaround also, which is faster and easier, is export the plant list to Excel and then add your own data, whatever the price or whatever. But
yeah,
it's
but
not
that's kind of
yeah. It is not
it
for
seems
your
to me like
it
seems to me a bit more
there's another question from Dominic. In the documentation list for the plants, will it also be possible to show the hatch and not only the symbol? Yes, right now it is possible, Dominic. So can you get closer to plant list from top view, maybe? Let's see that from top view. Yeah. Okay. So here, as you see, plants. Well, in edit panel, maybe. No. Deselect that. Okay. In edit panel, if you go to edit panel, you see that we have crown drawing and the hatch. So you can enable or disable the crown drawing. Okay. So you can enable or disable the hatch pattern. And if you disable the hatch pattern, you don't see the hatch, or you see that. I don't know if that is something that you were asking for or no. Can you turn on your mic, Dominic?
Yes. Can you hear me?
Yeah.
Yes.
Yeah, I was more interested in, for example, for a forest, or if you have like ground cover, you can also show them in the 2D as a hatch. And then I would like to also in the documentation list to actually have the hatch represented. But for now, I think I can only see the symbol from the individual.
Yes, that's true. The hatch representation for ground covers is not listed here. It's listed only the 2D crown instead. So that's something that we may improve in future versions.
Okay, sure. Yeah, and maybe another question. I struggle a bit with when I make hedgerows, how I can do them nicely as in a documentation. For example, yeah, I can plant a row of trees and make them small, so I have a nice hedgerow. But then most of the time, the individual symbols are not visible, and then I struggle to represent it in the documentation. Maybe this is something for future to think how I can or how it is nice to document it.
I'm not sure to have understood you properly. Do you talk about plant rows or how they are
when
represented?
like hedgerows, like if I have a garden and then I have like a hedgerow that I cut topiary in a row, and then in the documentation, most of the time I do it now with a hedge, and then
I mean, maybe we can discuss later what kind of result you would like to achieve, and maybe we can explore different options to or assign new representations for the plants that are used in hedges or topiary elements, so it fits your needs.
Yeah. I was thinking about putting something on the mail, so maybe we can.
Feel free to email us.
Please write us down whatever you feel you are missing, or you have questions that we couldn't cover during the presentation. Maybe they already are available, but in case that they are not available, we are open to hear your suggestions and your requests. So thank you, everybody. Thank you, Frances. I don't know if there's any other questions or no. I think no, but yeah, just feel free. I just wrote down our email address. Just feel free to write us. Well, just find it in chat box. So just feel free to write us any questions or any concerns that you have regarding the program. Have a nice day.
All right. Thank you very much. Bye-bye.
Bye-bye.
Yeah, thanks a lot.